Okay, we are going to go back over quadratic functions, and today you're gonna be able to graph these without using a graphing calculator. We're gonna talk about the vertical stretches and compressions, and we're gonna add one thing, the domain and the range. The domain is all the x values, and the range is all the y values. So, do you remember, let's just revisit, when we did the functions, the family of functions, do you remember all the transformations? It was a C, and then it was an A, and then X. Do you guys remember this? This is coming back to you. And then plus D. Do you remember what A, B, C, and D did?
Yes.
A was a horizontal compression or stretch, and B was you shifted it left and right, right?
Yep, D was up
Okay,
and down.
do you remember what letter did A and B affect, the X or the Y value?
The X?
The X, you are correct. These two affected the X values. And do you remember what C and D did? C and D affected the Y values. Okay, now today, what we're going to be doing is working with quadratics, so everything's going to be x squared. There is not going to be an A value. So you will not have to worry about A. You're only going to be moving your x value left and right, and you're going to be doing these two things to your y value. So, the B value, you add or subtract the opposite of that to your x values. And the C and the D, you're going to multiply the C value by the Y, and then you're going to add the D value to the Y. That's basically what we're doing. So let's start off by taking a look at the parent function of the quadratic. How did we do our table of values? What did we do? We squared them, because that's the rule. The rule says to take -2, -1, 0, 1, and 2. And if we square them, we end up with 4, 1, 0, 1, and 4, right?
Mm-hmm.
We are going to use these 5 ordered pairs in all of the graphs. Okay, so now let's graph them. The vertex is 0, 0. And we have 1, 1, -1, 1, 1, 1, -2, 1, 2, 3, 4. And 2, 4, and then you draw your graph. It's a smooth curve with arrows at the end. Now let's talk about some main parts of the quadratic function here. What is this point right here?
Origin.
It's 0, 0. It is the vertex. When your parabola is opening upward, that is going to be your lowest point. So we call this a minimum value. If it were going upside down, like if it were like that, that would be a maximum value. So we need to add minimum, maximum into our vocabulary. So this is a minimum value. The axis of symmetry, it's an imaginary line that goes through the graph. It's not part of the graph, but it just is a guide to help you see symmetry in this picture. So what is the axis of symmetry? It's the line x equals 0. It's an imaginary line. It cuts through, it goes right through the vertex, and it has a name. The name is x equals whatever the x of the vertex is, okay? Now your domain. Your domain is all of the x values that you can plug in to this function. Is there any problem with squaring any number? No. So the domain is all real numbers. All real numbers. The domain for all of these will be all real numbers. It's not going to change. This is not going to change. Now there's different ways to write the domain here. You can write x, it's less than infinity and greater than -infinity. Here's another way to write it. And there's another way that we use in pre-calc. It goes parenthesis -infinity, comma, infinity. Those are all 3 good ways. I'm fine with ARN, all real numbers. Or you can use that notation as well. Now the range. The range is your y values. Can you explain in words what's happening to the y values? It's starting here and it's going up. So the y values are what?
Increasing.
They're increasing from where?
0 to up.
0. So the y values are greater than or equal to 0. You don't see anything less than 0, do you? So from 0 up, including 0, that is all your y values.
You flipped it over the x-axis, and then you were going down.
It would be y is less than or equal to 0.
So-
Yep, y is less than, we're gonna do a few of those. Okay, now, just like for linear equations, you had different forms. You had, for linears, we did y equals mx plus b. We did standard form, and we did point slope. Remember these three for linears? And you could rewrite one equation into the other forms. Well, the quadratic has two forms that are the same, but they look different. And the two forms are standard form and vertex form. What's nice, we're going to concentrate on vertex form. What's nice about the vertex form is you can get the axis of symmetry, x equals h, and the vertex real quick. We're going to concentrate on standard form in the next few days, but we're going to just look at vertex form, where the vertex is going to be easy for us to pick out, and same with the axis of symmetry, okay? So that, we have two different forms. Today is strictly vertex form. So now, this is what I want you to do. We're going to graph this without a calculator. I want you, in this box right here, I want you to write the parent function. You're going to get a lot of practice writing the parent function. We have -2, -1, 0, 1, 2. And you're going to put 4, 1, 0, 1, 4. That's the parent function. Now, remember my little rule here, y equals, it was c, and then it was x. There was an a here. We're going to skip a, minus b squared plus d. I skipped the a value. So we are going to do first b, then c, then d. So what is the b value in this problem? It's -4. So what are you going to do to your, remember what I said, this changes? This is going to change your x values. So you're going to take these ordered pairs, and you can actually go like this too. Put x, y. You're going to split this t-chart up. I didn't do it for you. Okay, so we're going to do each transformation separately so you can see what's happening. So start with b, this number right here. And you can write, I have a little box here for you to write in your own words. You're going to take the x value, these x values, and you are going to add 4 to them. This one is the one that you do the opposite, because it says -4. So you're going to add 4 to all these x values. Okay? So can you add 4 to these real quick and tell me what you get? 2. Add 4 to -2. You get 2. Add 4, you get 3. Add 4. Add 4. And add 4. Everyone cool? Okay. Now keep the y values the same. Okay, so we did b. Now we're going to move to c, which is the 3 here. This is going to tell you to multiply the y values by 3. Which y values? These ones. So you're going to take the y value and multiply them by 3, because that's a vertical stretch by a factor of 3. Which y values? These ones right here. So you're going to keep the x values the same and multiply these all by 3. You get 12, 3, 0, 1, I'm sorry, 3 and 12.
It's on YouTube.
Okay, so multiplying these all by 3, these are what you get. Now the last thing is this d value. Remember, this affects the y value. you're gonna take these y values and bring them down 2. You're gonna subtract 2. So, keeping the x the same, the 2, the 3, the 4, the 5, and the 6, you're going to subtract 2, and you get 10, 1, negative 2, subtract 2, 1, and 10. You're gonna see a little pattern here too. Now I want you to graph this, and you might be off the page, or off the graph, I should say. Over 2 up 10, these are 8, so it's gonna be like up here. Over 3 up 1, I'm sorry. Yes. I'm sorry, 2, 10, 3, 1, 4, negative 2. I'm going the wrong way, you guys. I'm so
And
sorry.
who's telling her that? Who's telling her?
Because I was graphing my.
I'm looking up there. 2, 10.
It's on YouTube.
It's okay. 3, 1. 4, negative 2. 5, 1. And 6, 10 is up. Let me get here. So, there is our picture. I'm looking at this and I'm thinking shift going 2 over. So these ordered pairs right here will give you the graph. Okay? So now let's talk about, look at our vertex. It went from 0, 0 to 4, negative 2. So what is our vertex? It is 4, negative 2. Can you look at this equation and tell me a quick way to get the vertex without doing what we did? So if I asked you strictly, what's the vertex? Is there a fast way you could get the vertex? What is it?
Switch the sign of
Yeah.
V.
Yep, switch the sign of V, yep, and what?
Go down 2.
In this right here, your D value. Switch the sign of B, and then your D value. Now your axis of symmetry will be x equals 4. Can you tell me how you get x equals 4?
From the radius.
You're naming the x value of the vertex, exactly that. So x equals 4, that's your imaginary line going through your vertex. Is our vertex a minimum or a maximum point?
Max.
Minimum. It's the lowest point of the graph.
I can't say it over.
Okay, your domain, what did I tell you the domain's always gonna be? All real numbers. In the range, can you describe the range? What's the smallest y value? Negative 2. Is it greater than or equal to negative 2, or is it less than or equal to negative 2?
Greater than.
Am I going up?
Greater than or equal.
It's greater than. So y is greater than or equal to negative 2. Now, is there a quick way you could get that? You look at the vertex, and it's the y value.
Wait, what did we put? We just circled minimum.
Minimum, it's a minimum, yep. Okay? Okay, let's try another one. It'll get better and better. All right, we're gonna graph y equals negative 2 and then
Minus 1,
parenthesis
4.
x plus 1 squared plus 4. So what I want you to do is state the points of your parent function. So negative 2, negative 1, 0, 1, 2. And you're gonna square these, so 4, 1, 0, 1, 4. Now we start with the b value, which is right here, plus 1. So what are you gonna do to your x values? You're gonna take your x values and do what? No, not add 1, subtract 1. This one's the opposite one. That's the opposite one. You're gonna subtract 1. So I want you to take your x values and subtract 1. What do you get? Negative 3, negative 2, negative 1, 0, and 1. Now keep your y's the same. We're going to do it step by step. Next one. Go to your b value, or your c value, I'm sorry. X and y. What does this tell you to do? Multiply the y values by
Negative 2.
negative 2. So I write myself a little note there. So I'm going to take my y values and multiply them by negative 2. What do you get? Right? Keep the x's the same. The last thing, this 4, what does that tell you to do? Take your y values and add 4. Take your y values and add 4. Okay, so if you added 4, what do you get?
-4, 2.
Add 4.
4, 2.
Add 4, add 4, and add 4. Notice the pattern here. These should be the same. -3, -2, -1, 0, 1. So let's graph these 5 points. So -3, -4, 1, 2, 3, 1, 2, 3, 4. -2, and then 2. -1, 1, 2, 3, 4. 0, 2, and 1, -4. Do your dots line up like mine? Okay, now draw your graph and give me the information in the chart. What's the vertex? -1, 4. Does it make sense? The equation and the graph. We want to be able to go from a table to a graph to the function. How about your axis of symmetry? What are you going to write? X equals what?
-1.
-1. Is this a minimum or a maximum?
Maximum.
It's a maximum. It looks like a roller coaster. You'd be at the top of the roller. The vertex is a maximum. Okay? What's the domain? All real numbers. And can you tell me the range? What? What's this y value? What? Y is less than or equal to? Look at your y value, 4. And this is a typo right here, ignore that. So your vertex is going to give you a lot of information. It's going to give you your axis of symmetry, and it's going to help you with your range, your y value. Y is going to, in the fact that it's the vertex is a maximum, your y values are going to be less than 4, less than or equal to 4. Hopefully this makes a little bit of sense to you. Are you getting these? Yes or no?
Yes.
Yes,
Yeah.
okay. Let's try another one. So what do we do? Y equals x squared. What do we put here? -2, -1, 0, 1, 2. So we have 4, 1, 0, 1, 4. What's our first thing we're going to do? X minus 2. Good job. Take your x values and subtract 2. So if we subtract 2, we get -4. Subtract 2, we get -3. Subtract 2, subtract 2, and subtract 2. Keep your y's the same. 4, 1, 0, 1, 4. You really have to concentrate on these because it's very easy to make a math error. Okay, so next, what do?
Y times -1/2.
Take the y values and multiply them, so you can write -1/2 times the y. That'll help you. In your own words, you do what you want in this little box. So if we multiply these all by -1/2, we are vertically compressing and we're flipping it over the x-axis. We're doing it all in one shot. So -1/2 times 4 is -2. -1/2 times 1 is -1/2. Anything times 0 is 0. We get a -1/2 and a -2. Keep your x's the same. -4, -3, -2, -1, 0. What's the last thing we're going to do? We're going to take our y values and bring them down 1. So we're going to subtract 1 from our y's. Tell me what you get. Subtract 1, what do you get? -3, subtract 1. -1/2, -1, -1/2, and -3. Keep your x's the same. -4, -3, -2, -1, and 0. Graphing those 5 points over 4, 1, 2, 3, 4, 1, 2, 3, over 1, 2, 3, down 1/2, over 2, down 1, And then we have our symmetry here. And we are going to connect our dots. Now tell me the information I need in this chart. What's our vertex? -2, -1. Axis of symmetry is x equals -2. This again is a maximum. Our domain is all real numbers, and our y values are less than or equal to -1. Easy? Okay, next. Now, we are going to take a picture and go from a picture to an equation. What two things do you need to write an equation? The two things are the a value. We need x and y. X and y will stay in the problem. But we need the a value, which we don't know, and we need the vertex. The vertex we can pull out of this problem. What is the vertex? Can you name this vertex?
2, -5.
2, -5. I'll take it. 2, -5. Where does 2 and -5 go into this equation? The 2 is going to go here. You're going to put the 2 here. And we're going to put the -5 here. Does everybody agree with that part?
Yes, ma'am.
Now, we don't know the a value, but we've got a bunch of ordered x and y values that we could use to plug in. This is, remember, this is y, and here we have an x. So we know how to solve equations when we have one variable. So they gave you an ordered pair, 0, 7. You can plug this ordered pair, x and y. X is 0, and y is 7. And what variable are we going to look for now? A. Because once we get A and we know the vertex, we have our equation. So you learned in middle school order of operations. So what should you do first? Parentheses. What is 0 minus 2? -2. Then what do you do?
Exponent.
Square it, so you get 4. So you have 4, this is what you have. You have 7 equals 4a minus 5. Now what would you do? Add 5, you get 12.
A is 3.
And A is 3. So now, what we're going to do, we're going to go back to this formula right here, and you're going to put a 3 here and the vertex. That's all I need you to do. Everything else stays. So your equation is going to be y, or f of x, equals 3. The 3 is what we just found. And then x minus 2, and then minus 5. Oops, forgot to square it. Easy? Now, the only thing different about the next problem is they don't give you a picture, but they give you the vertex and they give you an ordered pair. So it should even be easier than the last one.
Wait, you don't want us to solve it?
Nope, just leave it like that. That's the equation. This is the name of this function right here in vertex form. We're going to stick with vertex form. So the last example, they give you the vertex 3, 7, and they give you a 0.94. You're going to drop these 2 points where they go in this equation. So tell me what you should put where. The vertex is your h and your k, and this is your x and your y. So what will we start with? Let's go left to right. What's your f of x? 4. So 4 equals, we don't know a, so that's our variable. What's our x value that they gave you? 9. What's our h value? 3. You're going to square that, and you're going to add, what's the k value? 7. Okay, we can handle this. Order of operations says you're going to subtract these, so 6 squared is 36, right? Then what?
X, or minus 7.
Minus 7, and you get, what's a? Is it -12?
No, it's 120.
It's -1/12. It's bottom heavy. So I brought the 36 divided by 36 and I reduced. Did I confuse anyone by going fast? Did I go too fast? Questions? Now, what do? Grand finale, what's the answer?
F of x equals.
F of x equals. F of x equals negative 1/12, parenthesis x,
Don't you plug in?
No, because you want it back.
you want x and y, and you want your vertex in the a value.
So the first one we did was plug in X.
Yeah, we did. We plugged in 0
Okay.
and
Not for
7.
the final answer.
No, we have right here. 3. We have 3, we have our x and our y. We did the same
Exact.
thing. Got it?
Yeah.
I have a question.
Yes.
I'm confused on what each order here means, like in the equation.
Okay, let's go through this. The vertex, see this vertex? This is your H value, or the B. Remember we talked about B and D? That's your B value, and this is your D value, but they use H and K. So these are the two right here. So the vertex goes, the X value of the vertex goes here, and the Y value of the vertex goes here. And then the X and the Y value that they give you are these, this is the X and the Y. Okay? Questions? Okay, now, here's your assignment. You can stop recording.